Here are the best practices that we usually cover in meetings like this. So I'll just quickly explain the need for districts. So here, the problem that we're solving with districts is this. We want to give each gear 5 external ports that they can communicate on inbound into the gear. So like if you have a MySQL database, we want to have an external port that your web gear can hit the MySQL database on that external port. And we want to give each gear 5 ports by default. And the problem is that there's only 30,000 ephemeral ports in TCP, or at least that's how Linux has divvied them up. And so that means that we can only have 6,000 gears. Obviously, we want to be able to grow bigger than 6,000 gears, and so that's the point of districts. Districts is a logical grouping of nodes where a gear will live, and then what it does is it allows you to give each gear 5 ports, and it also allows you to have the ability to move that gear to other nodes within the same district without having to reassign which 5 ports that gear has. So that's the problem that we're trying to solve, or that's the problem we're solving with districts. Now, it gets to a problem. There is a problem, though, in that if you have all 6,000 gears in the district consumed, but you have active capacity on the nodes left, that active capacity is actually wasted. And this is actually something that we ran into in production, and so that's where this best practice comes from. And it turns out that it's actually really simple to avoid this problem by doing some minimal planning up front. It's also you can also solve the problem after the fact. It's just harder, and so it's best to do some planning up front. So this is a formula that we came up with, and basically what it does is it takes your target idle percent. So that's what you hope to achieve. So like if you think that around 90% of your gears will be idled and 10% will be active across your entire production infrastructure, then you would put in here, you would put 90, and so 0.90 because it's a percent. And then what you do is you take the max active gears on that node type. And then what you do is you also take the max district gears. And right now it's 6K, but we're looking at ways to expand that higher. But currently it's 6K, so that number is already set. Here's an example. If you take 90% target idle percentage and you have 40 active gears per node and then 6,000, here's the math that works out. So basically in this scenario, you would have 15 nodes in a district maximum. Now that doesn't mean you always have to add 15 or whatever. It means that what you can do is you can start with 1 or 2 or 3 in the district, but the maximum you should ever have in any single district is 15. And what that'll do is that'll make sure that you won't ever have active capacity that's being wasted. So when we do this equation, we come up with 3 based on our variables. And so in all of our districts, other than the ones we started with, in all of our, since we implemented this best practice, they've all been 3 from then on. So okay, so if you fail to do this, and this is what we hit, what you have to do is called district compaction. And basically what that is so for us, we have the number 3, right? So if we have 5 nodes in a district and we have wasted space, what we have to do is we have to select one of those nodes, usually the one that has the lowest number of gears on it, and you have to move all the gears off of that node and onto other nodes in the district. And then once all of the gears are moved off of that node, then you can remove that node from the district. And that's the process that we've had to go through with our older districts. So again, you can absolutely recover from this and get out of it. It's not like you're completely trapped wasting active capacity, but it's just something that you want to avoid. This best practice recently was added to the admin console, which that's obviously different than the user console. In the admin console, you can actually set variables. You can set these variables. I think they're named something else, but they're similarly named. You can set these variables, and then when you're looking at the actual district, it will, if you're past this suggestion, it will actually pop up and say, you're past this best practice. We recommend, that you lower the number of nodes in the district. So, okay. So that's the basics of our district planning best practices. We highly suggest that you do something similar to this, if not this exactly, simply to avoid this problem. To move the gears, you're going to take downtime. So basically what it does is it stops the gear on the current node that the gear is on. Then it does an rsync of that gear over to the new place. Then it starts up the gear, then it changes the DNS. Then it starts up the gear, and then it finally, if all of those steps have succeeded, then it removes the gear from the original node. So basically, it's built such that it's the most secure way of moving the gear, if that makes sense. Because if you move the gear and it fails to start up for whatever reason, it will revert the change and put the gear back, and start the gear back up on the original node. And so in that case, you're basically no worse for the wear. What you do is you get a list of all the gears on the node, and then OOadmin move takes a gear UUID. Okay, on to our monitoring best practices. So here's what we monitor on the brokers. Now, we obviously monitor more. We monitor disk space and CPU utilization and a bunch of other things. But specifically for OpenShift monitoring, these are the things that we like to monitor. So OOadmin check. What OOadmin check does is it does a consistency check between what's in Mongo and what's on the X nodes, or nodes. Sorry, we call ours X nodes, so execution nodes. So anyways, so the nodes, and what it does is it makes sure that anything that's in Mongo is also on the nodes, and anything that's on the nodes is also in Mongo. It also does a bunch of other checks, like it makes sure that the SSH keys are properly deployed in the gear like they should be, and different things like that. So we actually monitor this. There's level 0, which is rather quick to run, and then there's level 1, which is much more intensive. So it just does more checks that take a longer period of time. We run level 1s every Monday, and we run level 0s every other business day, every other business weekday. So we also run OO except broker. So we actually love having these as checks, because not only do they tell us that our system is set up properly, but they tell us that our system continues to be set up properly, if that makes sense. We use Puppet for our configuration management. So if an admin accidentally pushes something, a config that breaks one of these, then it will alert and we can go quickly take care of that. Also, we run all these in our staging environment, so when they push it to staging, it will alert us, and so we can see before we even go to production that that change is a problem. So, so we also have an application creation check that we run that every 5 minutes. And what it does is it's literally just an application creation loop. It creates an application, then it deletes it. It creates it, deletes it, and then it flags whenever it fails either of those operations. So that's the purpose of that, is just kind of a general sense of what our users are seeing. We actually run this from each individual broker. So if one broker fails to create apps for whatever reason, we can zero in on that broker. We basically just create this application one time, and then we hit the we just call RHC app status on that guy, or actually app show on this guy, and we can see his status. And the purpose of this is it's a much lighter weight check of application than the application creation, but it gives us back the fact, it tells us that mcollective is working, ActiveMQ is working, and that node is working and whatnot. So it's a lighter check that we can run more often, that gives us a better sense of what's going on. Okay, and also we do an RPM consistency check. The RPM consistency check, what it does is it actually grabs the RPM list from all the brokers, including the versions of the RPMs, and then it compares them with all the other brokers. And the purpose of this is that we want our brokers to be 100% consistent with each other. So we use Puppet to make sure the configs are consistent, and then we use the RPM consistency check to make sure that what's installed is consistent. Consistency is actually really important to OpenShift to give the users a consistent experience. And so this is one of the checks that we do to ensure that. Another thing we do is MCO ping. And what we do is we actually compare that with what's in the districts. So we go and grab the list of nodes that are in the district, then we do an MCO ping, and we look at the two to see that every single node that's in a district also is pingable through mcollective. And in that fashion, we can actually see if that node is having problems with its mcollective. We can see that right away. And if the broker is having problems, this check actually reports two separate items in our monitoring. One is the broker having problems with mcollective, and the other is the node having problems with mcollective. And so this check actually will alert us to both. Again, it's the same as if all of the brokers are having problems with this one node, then that node's having a problem. If only one broker's having problems with that node, then it's likely just that broker that's having a problem. Okay, and then we also monitor our Apache processes and like the actual process in memory, but then we also monitor the port to make sure that the port is up and taking connections. And finally, we monitor capacity. So, and what we do for this is we actually call into OOStats. OOStats has a nice feature where it'll give you back YAML output, and so we call into OOStats, get back the YAML output, and then report to our monitoring how many available gears are there in each of our node types. So we have small, medium, and large, and so it'll tell us exactly how many gears are available in each of those. And then we have set levels in our monitoring to say, alert us when that threshold is below a certain number. So, okay, so that's what we do for the brokers. Here's what we do for the nodes. Okay, so again, we really like the OO-accept scripts, and we like to monitor them. OO-accept node is actually even better than the OO-accept broker, because OO-accept node not just looks at the node itself, it actually goes and looks at the individual gears. So it'll tell you things like, it'll tell you if a gear's processes are not being confined properly by C groups, it will tell you. It'll say, this gear's process, this PID is not in the proper C group. It'll also tell you if the gear is missing a front-end config. So if we don't have our proper Apache front-end config for this gear, it'll tell us that. And it just does a bunch of different checks for us. And so we actually monitor this quite a bit. I believe we monitor it 3 times a day. So yeah, we really like OO-accept node. And then we do the exact same RPM consistency check, but only with other X nodes. So we group them into the different groups of node types, and then we do the consistency check just in those subgroups. So and then we also do Apache process and port for the front end configs. SE Linux status, so we ensure that it's always enforcing. This is, for us, it's extremely important because we rely on SE Linux. I mean, we do, for security, we do user separation, we do PAM namespacing, we do all these other things, but SE Linux is one of our core technologies that we use for securing the environment, securing the gears. And so this is extremely important for us, and so we monitor that SE Linux is properly enforcing at all times. We also monitor IP table status. So, so we use a lot of IP tables rules in order to segregate our gears into their different containers. And so it's extremely important also that not only is IP tables up and running, but that it has all of the rules loaded. And so we specifically monitor that. So yeah, so it's extremely important to keep the X nodes as similar as possible, because if you don't, when someone creates an application, creates a gear on a node, and if they scale that node, those two gears could have different behaviors based on what's installed, like if you're missing a library, like a system library or something like that. And so it's extremely important to monitor to keep them as similar as possible. So again, we only do it right now. We only do it every 3 weeks. I mean, we can run it ad hoc, of course, and I do from time to time. But we only run it every 3 weeks. But we find that that's pretty good. It tells us whenever, like on our team, we have the rule that nothing goes out unless it's in Puppet, and so based on that, we're actually pretty good at obeying this rule anyways. We just like to run it as part of our deploy to ensure, that everything is properly in sync with the other X nodes. So, all right. The next thing that we want to talk about is how to monitor the Mongo nodes. So what we do is we monitor the replica set health, we monitor the database size, the addition and removal of indexes. So the addition and removal of indexes is actually extremely important because if you don't have the indexes that you're supposed to have, you won't get the performance out of Mongo that you expect. Now, in OpenShift's case, our broker ensures this. So when our broker starts up, it actually goes out to Mongo and adds the indexes if they're not there. So this is actually we just like to see this so that we can see if things get removed that aren't supposed to be removed and whatnot. But for the most part, we don't actually have to ever deal with the Mongo indexes. The software, OpenShift itself, handles this for us, which is very nice. And then there's a whole list of other database-related metrics. There's an open source project out there called Mikumi, and what it does is it gives you a Zabbix template and items and triggers and all the different things that you would need to monitor Mongo, and it also gives you scripts that will fill in those values from Mongo. And so we actually use Mikumi to monitor our Mongo nodes, and we really like it quite a bit. So again, we do the consistency check with other Mongo nodes to make sure the RPM consistency check to make sure that they're in line. We monitor the process and the port. And specifically with the replica set health, it's extremely good to know if your replica set is having any problems whatsoever. So I would highly recommend if you don't use Mikumi to use something to monitor your Mongo replica set to make sure that you know whenever one of the nodes is not healthy. The other thing is there's an operation time, and we actually monitor this as well. And what the operation time is it shows you how up to date each of the replica set members are. So when you're inside of Mongo, if you do an rs.status, open parenthesis, close parenthesis, it will tell you the operation time of each of the nodes. The operation time is the time that the last operation executed, if that makes sense. And so what it'll do, so the same operation when it executes on the Mongo node will set the time on the primary node. It will set the operation time on the secondaries to that same time. So what you can do is you can compare the times of the primary to the times of the secondary, and if they're out of sync, you can set a threshold to say, well, don't let this ever be more than 15 minutes out of sync or an hour out of sync or whatever you feel is a good threshold. And or actually, it won't say don't ever let it go out of it. It'll say alert me if it ever goes out of it. And in that way, even if Mongo hasn't detected that there's a problem on the node, if it's that far out of sync, if the secondary is that far out of sync, there's a problem. And again, these are all things that Mikumi gives us. So for security best practices, this is how we handle it. We monitor all of our nodes for new security updates, and basically what we have is we have a cron job that goes out and runs yum and says give me the list of all the new security updates. And then what we do is we alert whenever they come out. And what we do is, I think this is standard practice, but what we do is we first install them in our staging environment and make sure that they don't break anything, and then we install them into production. And then after we install the security updates, the gears will see the security updates, but they won't necessarily be running on the security updates. But they all, just installing the OS security updates gives them the ability to use them, which is actually very nice operationally. And then what we do is we actually have to go in and say, okay, this is a PHP security update, so we need to restart all of the PHP gears, or this is a JBoss security update or a Java security update, so we need to restart the JBoss gears. And there's another thing that you can use. There's a tool called needs-restarting, and what that'll do is it will tell you any processes that are currently running that are using the old libraries. Like they've loaded the old libraries into memory and they're using the old libraries. And so this basically is saying this process needs restarting. So you can also do that to find out which gears need to be restarted. It doesn't work very well with Java, unfortunately. But for the other types of cartridges, it works pretty well. So here the example is, if you have 100 PHP gears and you only have to install the PHP update one time and then restart the different PHP gears. So each individual gear doesn't need to have its gear updated. So we run yum, and we do the list security, and then basically and then we trigger off of that. So we grep the number of important or severe, and then we do a -c or whatever to see the count, and then we put that in Zabbix, and then we trigger off of if it's greater than 0. Onto our Xnode best practices. So we put var lib OpenShift onto shared storage. In this way, we can actually take a node, and if the node goes down, we can detach the shared storage, create a whole new node, and attach the shared storage, and then be up and running with the gears, in a matter of a few minutes. Because we use Puppet, all of our stuff, we can recreate these new nodes, and we actually use a node image, a clean node image to create the Xnodes. We used to create them completely from scratch, like basically we do the workflow of doing a kickstart file and then running Puppet and doing yum updates and different things like that. We used to do that, but that ended up taking a really long time. So what we do now is after each release, we will take an image. We have a clean node image that the node hasn't been used for anything else. And what we do is we boot it, we update it to the latest, and then we take an image of it. And in that fashion, we can actually get our node creates down to roughly like 10 minutes. And so basically, if any single node completely goes down to the point where we can't reboot it, we can't stop and start it, we can't there's just no way for us to recover that node, we'll detach the shared storage, create a completely new node with the same name, point DNS to the new node, run Puppet to get it up on the latest Puppet config since the image was created, and then attach the shared storage, and off we go. So that's how we use it. It's really nice for us. It gives us a safe feeling so that if any disaster happens, we can easily recover, or relatively easily recover from it. We use Puppet for our configuration management, but it would, this type of system would work just as well with Chef or Ansible. We don't have anything proprietary in Puppet that keeps us linked to Puppet. In other words, we just use it for normal configuration management. And then whenever we add a new node, we make sure that all of our monitoring checks, so we don't just run our except node and stuff like that. We run all of our monitoring checks on the new node before we actually add it to a district. So a node that's up and running will not be used until it actually goes into a district. And so we use that as a way to bring our nodes up, fully test it, get everything working, or make sure everything's working, and then finally, once we're confident in the new node, we put it in place. The other thing is, so the 10 minutes that it takes to put up a new node, we actually use that for our node creation, so as we scale as well. And the nice thing is it takes 10 minutes if we want to add one node, or if we want to add 10 or 20 nodes. Like it's infinitely parallelizable in that regard.